Good afternoon, everybody. As was mentioned, I'm presenting ongoing work titled Perceptions, Barriers, and Integration of LLMs Across the Cybersecurity Workforce. So by now, I'm sure that we've all seen how LLMs are being pushed to us from every single direction. And with the promise of what exactly? Well, the promise of increased productivity, right? And in cybersecurity, that is no exception. In fact, in the last couple of years, research has shown that LLMs can be effective for a range of security tasks, such as identifying novel malware, reverse engineering malicious code, incident response, as well as generating malicious code, particularly for penetration testing as well as for malicious actors. So in theory, it seems like LLMs might just be the answer to all of our prayers, because if anybody stands to benefit from increased productivity and automation, it is our cybersecurity workforce, because their work is working tirelessly every single day to defend our systems against malicious actors, right? But the real question remains, are the research applications actually being put into practice? So far, there has been no studies to understand what is actually happening in practice. And this is where our study comes in. We're currently conducting semi-structured interviews with cybersecurity professionals to understand what are their perceptions of LLMs, of cybersecurity practitioners. Is it something that they're hesitant? Are they optimistic about it? Kind of what is the lay of the land here? Are they currently using LLMs for security tasks? If so, how? And what are the advantages and disadvantages that they've seen from the products that are out there for security tasks in particular? And lastly, are there any barriers to adoption, whether that's a technical barrier or any policies that there might be in place? So while we're still on the early stages of data collection, I wanted to share some preliminary findings. Let's start off with strengths. So quite a few participants have mentioned that LLMs are pretty good at pattern matching, specifically to detect anomalous behaviors. So the effort that normally would take weeks, if not months, for a human to go through all of that data and identify that needle in a haystack is something that an LLM can do pretty quickly. Another one is reduction in analysis time, particularly when writing scripts for, let's say, something like decryption or unpacking, which is something that they have to do on a routinely basis. On the flip side, the weaknesses. This is one that I wanted to show because it might be somewhat interesting, and it's something that I was certainly not expecting when I heard it from participants, which is when we asked them what are the weaknesses of current LLMs, one participant expressed this explicitly, saying, I can answer this one real fast. Report writing. Anybody in cybersecurity will tell you the biggest time sink is reporting. LLM can usually write about half a page, but after that, it starts going crazy. I'm guessing that's based on context window. Another more general, I guess, weakness of LLMs that most of us might be familiar with is the fact that you have to verify the output, because there could be hallucinations or misinterpretations. But more specifically, they mentioned that you not only need a human to actually verify, but you need someone that is expert in the field of cybersecurity. As one participant pointed out, I typically am asking questions that I know the answers to. I kind of know what the answer should look like, and that's how they verify. Though that might be a negative side, it also explains kind of the sentiment of why a lot of the people that we interviewed said experienced practitioners in the field are not concerned about being replaced. Someone stated, I don't see an AI being able to fully replace us. A lot of what makes a person good in incident response is their gut feeling and their understanding. So, future outlook, where do they see things going in the near future? Although they mentioned that LLMs may not replace them, at least not in the near future, they may replace what is known as signature-based detection and fundamentally change the role of security operations center analysts, because they're the ones that are currently writing up the rules to detect malicious software with these rules. So one participant said, I think SOC analysts as we know them today are a dying breed. They're going to have to evolve, become better interpreters of what's provided to them, and be able to use prompting. So to summarize our findings, some of the benefits are the fact that it reduces time needed for detection and development of analysis scripts. The disadvantages, however, are that they still require a significant amount of supervision, specifically from experts. And lastly, future outlooks is that although they may not replace the current practitioners in the near future, they may fundamentally change roles as we know them today. And with that, I'm happy to take any questions.
All right. Hi, everyone. My name is Wen Tao, and I'm going to talk today about some work in progress on de-identification tools for researchers. So, I want to start off by saying that sharing research data has many benefits, right? So, pharmaceutical companies will publish clinical trial data, and this enables scientists to verify the safety and effectiveness of new treatments. Similarly, foreign aid organizations will publish data about program outcomes, and this enables journalists to report on whether tax dollars are being spent ethically and impactfully. This is not to mention that sharing data can also expand the horizons of research, right, by enabling, for example, meta-analyses that draw conclusions about large bodies of work. And for these reasons and more, publishing research data is becoming increasingly a requirement for publishing a paper, for receiving research funding. However, if individuals are re-identified, sharing data can also cause harm. Clinical trial data can reveal participants' physical and mental health to employers and insurance companies who might use that information to discriminate. And foreign aid data could also reveal participants' political sentiments to local organized crime and terrorism groups who might use that information to target intimidation and violence. So, the typical expectation is that when research data is published, it is de-identified. And what I mean by this is modifying data to make it more difficult to re-identify or learn information about individuals. It turns out that effective de-identification is actually really tricky and has been the subject of a great deal of privacy research. Our prior work with researchers shows that, in practice, DID is time-consuming and provides unclear privacy protections. Some researchers already use tools to scaffold this process, but they're wary of the impact on utility of the data that might be had by applying more rigorous de-identification methods, such as the ones that might be used in more sophisticated tools. So we think that there's kind of a potential niche here for tools to help. Right, so tools could help by unlocking methods with stronger privacy, by improving usability with visualizations and interactive features, and by illuminating trade-offs between privacy and utility. So, where do we start? The good thing is that de-identification tools already exist. There are several of them, many of them are actively maintained. The bad thing is they're unlikely to be useful to most researchers. They have limitations ranging from issues with usability to performance to the kinds of privacy models and algorithms that they support. And also just in general, they tend to be designed for users who already have significant expertise in de-identification, not your typical researcher. So we're trying to kind of, given this tension, we're designing a study that mixes methods to make the most out of the situation. So in our study, participants will do some co-design of de-identification tools to try and ideate about their ideal tools for their research contexts. And they'll also interact with an existing tool as a design probe. In other words, as an open-ended, thought-provoking exercise, rather than, say, a usability study. And then the study will conclude with some reflection on their experience through a semi-structured interview. And the research questions that we're interested in are what kinds of workflows and capabilities researchers want from de-identification tools, and how they think through this process of, did this tool produce an acceptable output? To overview our study a bit, we're recruiting researchers from UND and also the George Washington University. We're conducting 75-minute sessions with a $60 cash incentive. And in the study, participants will work with modified data from the 2023 Detroit Metro Area Communities Study. And so this data includes information about health and disability, finances and employment, and also detailed demographics. The de-identification tools that participants will work with, there are 3 of them, and each participant will interact with one. They'll use it to de-identify the data sets with detailed guidance from us. And the 3 that we're using are STC Micro, ARX, and a combination of MST, which is an algorithm for generating synthetic data, and ST-Metrics, which is a data visualization dashboard. The first 2 of these tools, STC Micro and ARX, achieve k-anonymity by grouping values into categories and deleting data. They take slightly different approaches towards this. And MST generates differentially private synthetic data. And together, these represent more or less kind of the current state of the art in de-identification tools. So I'll finish by saying this. We are recruiting study participants. We're looking for grad students, faculty, and staff at UMD and GW. They must be able to meet in person on campus, and they must have experience with quantitative human subjects data. If this sounds like you or someone that you know, please reach out, or there's more information at this QR code. Thank you.
Right, thank you. Hello everyone, my name is Sonia. I'm a PhD candidate in information studies. Today I'll be talking about my dissertation on protecting unintentional users' privacy in smart home environments. So the context of my dissertation is homes that are equipped with devices that connect to the network to provide some kind of value to customers and end users. These could be smart speakers, providing convenience, smart doorbells, providing security, smart TVs, providing entertainment. While these devices provide value to customers and end users, they also bring in privacy risks because these devices collect, analyze, and share user data. However, the implication for privacy is not equal to everyone. So people with different levels of access and control have different implications for their privacy. And the users that I'm interested in studying are unintentional users. So these are people who interact with smart home devices without having access and control to them. Examples could be being a guest or visitor at someone's smart home. Some specific examples could be delivery workers having to interact with smart doorbells, or domestic caretakers having to interact with smart devices for pets and babies, and etc. The important point here is that unintentional users have faced greater privacy risks because, again, they don't have access and control of these devices that collect and use their data. The problem here is that the existing privacy protecting mechanisms and tools usually have users in mind, and they assume or require some sort of access and control of these devices that unintentional users don't have. So they don't really meet the needs of unintentional users for non-technical mitigation strategies. And the non-technical mitigation strategy that I'm interested in is in communication. So my dissertation explores communication possibilities between primary and unintentional users in smart home environments. My dissertation consisted of 3 studies. The first study is understanding the perspective of primary users about their willingness to accommodate non-primary users' privacy. I conducted interviews with 15 short-term rental hosts about their usage, management, and disclosure of smart devices. The second study, I tried to understand the perspective of unintentional users, privacy wants and needs in smart home environments, where I interviewed 25 unintentional users about their experiences and expectations of privacy when having to interact with smart home devices. The last study that I'm conducting right now, and I'm going to elaborate further, is trying to understand how people negotiate their privacy, their processes and values embedded in them. So to understand privacy negotiation, I am conducting focus groups with co-design activities, trying to answer the question of how might stakeholders, so primary and unintentional users in smart home environments, to prevent, negotiate, and also resolve conflicts around smart home device usage. The focus group consists of three main activities. The first activity is a brainstorming session where participants talk about the implications of privacy of using these devices in various environments. The next activity is a privacy negotiation game where participants take roles to play a cooperative role-playing game, having conversations about how to use these devices in a manner that meets owners' needs and also protects guests' privacy. I have a good demo of this game prepared for the poster session, so please stop by and play. The last activity that I do is the participants create a rental listing with privacy in mind. So right now, I'm in the stage of analyzing data with qualitative coding and thematic analysis. Here, I map some potential codes and themes that would answer my questions. And due to the constraint of time, I'll talk about one question, which is prevention. So the codes that I'm looking for to answer prevention is around disclosure. How do people want to prioritize when they're disclosing about devices? What kind of tone and manner do they want to convey to guests and incidental users? And later, these codes could develop into themes such as guidelines and considerations on disclosing smart devices. So in summary, my dissertation aims to understand privacy negotiation to protect unintentional users' privacy in smart home environments because unintentional users are exposed to privacy risks in smart home environments without necessarily having the means to protect themselves. My dissertation is funded by the NSF, and here are my wonderful collaborators. Thank you.
All right, hello everyone. I'm Yunze, and today I will be presenting a qualitative analysis that we did on fuzzing 2 usabilities. So I assume a lot of people are not familiar with fuzzers or fuzzing tools. So what it does is they basically are a set of software testing tools, and it generates a bunch of random inputs to try to crash the target programs. So let's compare that with our familiar unit testing. So for unit testing, you will have a developer. You will provide an input and write a test. And you will pass it to the program will report a bug, or hopefully not. And for fuzz testing, it's a little bit more complicated, but it looks similar. So a fuzzer would generate the inputs. It will generate a lot of it randomly, and then it will throw it into the target program. And it will potentially create some crashes. However, this is not the end. The target program will provide feedback back to the fuzzer. And using those feedback, the fuzzing tool or fuzzers will create inputs that better targets the weaker part or the parts that are not untouched in the target software. However, there's more to that. If only it's that simple, huh? So for fuzzer to understand what's actually happening inside a program, it requires a specialized compiler. And during this compilation process, it will put actual code into the software. And that process is called instrumentation. Beyond that, the user also needs to write code that take the generated random inputs and pass it to the function that they want. And as you guys can imagine, the inputs are completely random, so users might need some processing to actually make the inputs accessible or acceptable for those target functions. And finally, fuzzing doesn't stop. It's a continuous process that don't have a natural completion point. It could run for days, months. Google even fuzzed Gemini for years, since it's out. And whenever a new version came out, they just start fuzzing that instead of the old one. And so based on that, user must actively monitor feedback and decide when to stop based on the instrumentation and the fuzzing harness that it provided. So to understand how these complicated process, whether or not it will create challenges or usability issues for developers or users of fuzzing tools, we propose our study with these 3 research questions. They're about challenges, which are what are the challenges the user will face when using fuzzing tool, and what are some of the workarounds, and finally, what are the suggestions that they will have for improving fuzzing tools. So for improvements, we recruited through GitHub and a lot of TOEFL conference papers. We just do straight up emailing because, as you guys probably expected, there's not a lot of people doing fuzzing. And we also find some social media communities on Discord and LinkedIn and distributed our recruitment message. And we conducted semi-structured interview with 18 participants that we recruited. It's usually around 1 hour with $75 incentives. And we have a even split between companies and institution, which is pretty nice. And most of the participants have more than 1 year of experience in using fuzzing tools. So the interview process is usually divided into 3 parts. First, we talk about how they prepare and execute the fuzzers, basically the usage of the whole fuzzing workflow. And finally, and then we ask them about the feedback that the fuzzer provide and how does that guide them to decide when to stop or to discover some issues in their harness or in the code that they write that guide inputs to to target functions. And finally, we ask them about what are some of the suggestions you will have for fuzzing tools. So I'll quickly go over some of the findings here. Some of them are a little bit more technical, but the few things I want to mention is the first, fuzzing is really powerful, which is good. A lot of participants recognize the power of fuzzing, and they are not just talking about it, and more than half of them repurpose them or even write wrappers or code beyond them to serve other tasks that's beyond fuzzer's original design. For example, we have participants doing reverse engineering using fuzzing tool. We have participants that using fuzzing tool trying to understand a old language called COBOL, and we have other participants doing hardware fuzzing using this, which is very non-traditional. What's more, participants really hope that research could focus more on usability rather than just performance, because fuzzing has this cool idea of just being dumb and fast. And a lot of research now is trying to make fuzzing smarter but also fast, which is good. But as we can see, a lot of times it takes a long time to set up the fuzzing tool. And even though it could be dumb and fast for the fuzzing process itself, the setting up process can be slow for developers. So they would really like to see some research in the usability parts of fuzzing instead of just performance. And finally, some developers or users mentioned about fuzzing should have a broader domain applications. As we mentioned earlier, fuzzing requires a specialized compiler that's usually provided by the fuzzer itself. So that's usually the bottleneck of why it has usually a narrower domain of applications. So developers and users really hope that fuzzer could operate across a wider ranges of domains and complexities, like IoT devices and also hardware and even AI models. Yes, I'll conclude with that. There's a lot more findings that are a little bit more technical. If you're interested, please come talk to me. There's also findings that we think are related to AI. There's a lot of people mentioning AI. I know I didn't mention any of here. And I know mentioning AI is like the hype right now. So if you're interested, please come talk to me. All right, that'll be it. Thank you.
So, hi everyone, my name is Peter, and today I will be talking about an early stage project titled Breach Notifications at Scale, Perspectives from the Breached. So every year, more and more data breaches are occurring. In 2023 alone, there were a reported 3,205 publicly reported data breaches, and this impacted an estimated 349,221,481 individuals. And this represented a 78% increase in data compromises compared to that of the previous year in 2022. And so to better illustrate this growing data breach problem, we have a figure here that contains data from 9 states across the country. And so you can clearly see the rising trend with data breaches over time. And so to help address this data breach problem, we have created the Breach Notification Database, or BNDB for short. And so the database itself contains thousands of publicly released company data breach records from various state attorneys general across the country. And it contains some key data fields that include but are not limited to organization information. So that would include the company name, industry type, and the size of the company through an employee count, as well as breach details. So when did the breach occur, or what types of data were affected? And lastly, impact metrics. So how many individuals were actually affected by the data breach? And so beyond serving as a database to just collect and store and clean the data, we also plan on using the BNDB to serve as a contact source for employee interviews, which I will touch more upon in the coming slides. Now, for insights, the database is useful in that it allows us to very quickly and easily identify repeatedly breached organizations across various states, company sizes, and industry types. It also allows us to track patterns across various industries and company sizes, as well as analyze breach types and frequency at a national scale. And so here we have a pie chart containing the various industry types represented in our database. What's particularly interesting to me here is just the sheer diversity of industries represented. And so we have everything here from law firms to universities, nonprofits, and government agencies. But the two most commonly affected industry types here are healthcare organizations. So that would include hospitals and clinics, and financial institutions like banks. And so for our project specifically, we want to focus on the experiences of breached organizations or companies rather than the individual, because while individual victims' perspectives are well documented and studied, there is limited work on the perspectives and lived realities of breached organizations and companies as a whole. And so our goal with this project is to really understand what a data breach is like from an organization's perspective, and hopefully we'll be able to obtain this information through our interviews. And so for our interviews, we plan on contacting organizations or companies that have experienced multiple data breaches within the same state in a single year. And in practice, what this will look like will be roughly 60-minute semi-structured interviews via video call with audio recorded only. And ideally, we'll target somewhere between 20 to 50 successful interviews. So in the interviews themselves, we plan on investigating these three primary research questions. So first, how is the company actually affected by the data breach? Second, why are we continuing to see recurring data breaches at the same organizations? And lastly, what resources would genuinely help prevent these data breaches from occurring both now and going forward? And so the research implications of this work are significant. We anticipate finding needs for more consistent reporting standards across states, providing better support mechanisms for small and medium-sized businesses that may lack the proper infrastructure, technologies, or financial means to properly mitigate their data breach issues. And finally, provide improved threat assessment tracking systems. So in practice, that would be organizations or businesses being able to use systems or tools that will allow them to continuously monitor and document their vulnerabilities or their data breach experiences. And so our timeline has us completing interviews by August, conducting data analysis through the months of September and October, and finally, ideally releasing our findings by December. And so ultimately, our work provides a unique perspective into the ever-changing data breach landscape by centering the experiences of the breached organization, not the individual. And through our interviews, we hope to not only develop targeted prevention strategies on an industry-by-industry basis, but also help mitigate the data breach problem, both in terms of frequency and impact. So if you'd like to learn more about our work, you can visit our website at bndb.umix.umd.edu, and I can be reached at this email address for any additional inquiries. Thank you for listening.